Hello, this is Kacper speaking. I'm the founder of the AMLC Foundation, a non-profit organization that tries to educate in AI and solve social issues by applying machine learning. I'm not going to make you bored by describing the whole foundation. If you would like to know more, please visit our brand new website embassy.ai. Today I'm going to talk about SmogSpots. This is one of our projects, actually the project that the whole foundation started with. SmogSpots is about applying machine learning for solving the smog issue, which is quite harmful for Poland, but also for Eastern and Central Europe in general. There are various reasons why the smog is still there. Partially it's caused by industry like factories or transport. The city centers are still full of cars, and that's one of the factors that influences the air pollution. However, in Poland, the major problem is caused by the individual households that uses bad quality furnaces or fuel like coal. That is why we asked ourselves a question: which areas contribute most to air pollution? If it's really caused by the individual households, then using some techniques in order to find those households might be crucial. And currently, some of the companies try to use drones in order to analyze the chemical structure of the smoke from each particular household which is accused of polluting the air. That method might be kind of efficient, however, still requires a lot of money. Those analyses cannot be performed directly by the drone itself. The samples still have to be analyzed by some sort of chemical laboratory. That's why we wanted to create a method that utilize what we already know in order to find all these places, all these areas that pollute the air automatically without analyzing all the individual households separately. And this is where we think machine learning may be applicable. This is how it started. SmogSpots is the winning project of Smogathon 2019. Smogathon is the hackathon organized annually in Krakow, and we were able to win the category Identification of Pollution Sources. We proposed a method that tries to measure the impact of the municipalities around Krakow to smog levels. The original problem to be solved by the competitors during the Smogathon was to assign how much each municipality, each area around the Krakow contribute to the smog levels in the city itself. We were able to predict the concentration of PM10 dust in the city based on some other measurements collected only out of the city in the past. So, in other words, if you were interested in the concentration of PM10, which stands for particulate matters with the diameter less than 10 micrometers, and you would like to know what the concentration will look like in the next hour, you can calculate that based on some other measurements collected in the past, let's say in the last day, in the last 3 days, only out of the city. The proposed solution is just like a basic idea that we still try to expand. However, I would like to talk briefly about the overall idea and how we currently try to improve it. During the Smogathon, we were provided with different data sources, and only 3 of them we found to be useful. The first one was created by one of the public agencies and consists of some measurements collected by the sensors which are thought to be highly precise. Another one, Early, which is a private company, contains a lot of similar measurements but the quality is significantly lower. And another public agency, contains weather-related measurements like temperature, wind direction and speed, air pressure, etc. By using those data sources, we were trying to predict the concentration of the before mentioned PM10 dust concentration. And we found out those three data sources to be the most useful amongst all. In order to answer the original problem, the original question of the Smogathon, we decided to make a model that tries to predict the measurements of those highly precise sensors, so the first data source, and predict how the present measurements in Krakow will look like based on the past measurements of the second data source, so the one with lower quality, and some weather related information. There were several issues that we had to overcome. The first one is that the data we received is unlabeled. It was quite challenging to assign the contribution to areas, and that was the original problem that the competitors were asked to solve. Due to that, we couldn't use supervised methods directly, and in order to find the proper answer to the question, we had to rephrase it a bit. Another problem was that the quality might be an issue. The precise data sources were quite limited, while the ones with high volume had rather low precision. Additionally, spatial relationships had to be kept, and this is not something that is so easily solved by typical machine learning models. So how we approached the problem of Smogathon 2019? We sticked to prediction of PM10 concentration of those highly precise sensors in Krakow based on the past measurements of those low quality sensors out of the city, together with some weather related information and geographical data used as features. In order to answer the problem of assigning the contribution to air pollution in the city to all the neighboring municipalities, we used some explainable AI methods and calculated the feature importance measurements in order to assign this percentage of contribution to the smog in the city. We proposed the following approach. So first of all, we collected the early measurements separately for each considered area, for each municipality around Krakow, and averaged them in several different time windows from 3 days to 1 hour. Those averaged features were enriched with some meteorological data for the same windows. So, for instance, what was the wind speed and wind direction in that time window, because that may influence how the gases transport in the atmosphere. Altogether, different models have been tested in order to predict the measurements of these highly precise sensors in Krakow. And the best model, according to R-squared, was further analyzed to determine the feature importance based on permutation importance, which is quite easy method, but surprisingly not so commonly used. This is how permutation importance method works. So permutation importance tries to measure how much each feature contributes to the whole model performance by comparing the value of the selected metric calculated on the original set with its value calculated on a test set where one of the features is randomly shuffled. By calculating those two values of the same metric, we are able to detect how much this feature contributes to the total result achieved by this model. Let's say we want to calculate the importance of the second feature visible on the right side of the screen, so the second column in the table. If we calculate the metric on the original test set and then subtract the same metric value but calculated on a test set where this particular feature is randomly shuffled across all the observations, then we are sure that the values for this feature come from the same distribution. Now we can calculate the decrease of performance by subtracting the metric value calculated on the shuffled dataset from the metric value calculated on the original test set. This might be considered to be an impact of this particular feature on the whole model. So how important this feature is for the overall performance of it. Surely this procedure cannot be done just once for a selected feature, because by random chance we could just simply got quite weird results, especially if our feature has just a few different values. So the whole procedure consists of repeating the process of shuffling of permutation for each feature multiple times, typically 10 or 20 times. And then the decrease of performance is averaging across all the different permutations. Permutation importance is useful not only to calculate the feature importances, but also to find out if some of the features might be unnecessary. Let's imagine that we perform a permutation importance for a particular feature, and it turns out that the model performance doesn't decrease, but instead it increases. We can then consider such a feature as totally unimportant for the model, because if it can perform better without this feature or with this feature randomly shuffled, then probably removing it from the data set might be kind of helpful for the whole model. The complexity of the whole system will be lower than before, and probably if the original model used this particular feature to make the decision, then it just learned some unexisting patterns in the data based on some random noise. So it's quite helpful. And that was the procedure that we used for all the features. The problem here was related to the fact that we were using some averaging methods. I mean, we were calculating the average measurements for selected low precision sensors outside the city, and these averages were just calculated from the same data. So we couldn't simply randomly shuffle one of the averages, but instead we had to operate on the original data set. So we were randomly shuffling the original measurements of the sensors and then calculating the averages once again. Mostly due to the fact that those averages were calculated using the same data, so we cannot simply change one of them and expect the rest to keep the same. Altogether, we were able to assign the percentage of contribution to every single municipality around Krakow and detect which of them contribute most to the air pollution in the city. This map doesn't cover one of the municipalities because this area didn't have any of these low precision sensors, and due to that we couldn't simply use that information to make our prediction. And additionally, it also doesn't contain the information about the contribution of the city itself. It may simply turn out that Krakow produces like 95% of the whole smog, and all the other municipalities just missing 5%. However, for the purposes of hackathon, we thought this method to be quite interesting and a good starting point to extend the whole idea to get some better results. First of all, let's consider how those numbers might help us to reduce the issue of smog. Basically, even though if we know which municipalities contribute most to the air pollution in the city, that doesn't change anything. It's like a knowledge that cannot be utilized in any way. It also covers something that's already known. I mean, all those municipalities have already tracked the smog, the air pollution produced by them. So probably that should overlap those results. So our numbers are not so useful. However, if we could be able to make it on more granular level for some villages or particular areas which contribute most, then maybe we could simply find not only the municipalities but people who are responsible for polluting the air directly. And that is why we found another approach that we currently try to investigate and develop. But before we start talking about this new approach, let's see some other numbers that may scare you. 6%, it's the yearly cost of smog as a percentage of Poland's gross domestic product. 72% of the most polluted cities in the European Union are in Poland. 3.75 times higher are the smog thresholds in Poland. That means that the smog alert is announced in Poland when the PM10 level reaches 300 micrograms per cubic meter, while the same smog alert is announced in Paris when it reaches only 80. 19 to 22,000 of people in Poland die prematurely due to smog every single year. Currently, it's rather hard to say that our government or some local authorities do nothing about the issue. There are a lot of different ways that they try to support those people who still uses old furnaces or the fuel of bad quality. There are a lot of different subsidies that are aimed to change those furnaces into some modern heating systems. However, there is another issue which is somehow related. Poverty. It's still a huge problem in Poland, especially in villages where a lot of people won't afford a new heating system. If we propose them to use electric power to heat their houses, they won't afford to pay the bills. Moreover, those people are typically digitally excluded. They do not own a computer or internet connection or don't use a smartphone. So even though our local authorities make a lot of different programs to subsidize the replacement of the old furnaces, those people might be just not targeted well. I mean, everybody in Krakow, when you go for a walk during the winter time, you will probably see at least a few posters trying to convince you that you can replace your old furnace or change the heating system of your house, but those people who are digitally excluded and just poor won't even see them. That means that making some new programs and trying to repeat the whole process are totally pointless. We need to find those people somehow in a different way and try to help them directly. That's what we at least believe in. We propose a new approach which tries to utilize not only those mentioned sensors, but also some other data that is publicly available thanks for some public programs of the European Union. There are basically three different goals that we would like to achieve with using that technique. First of all, we would like to improve the social awareness. If we find the people who are personally responsible for air pollution and educate them directly, it will be much easier to convince them to change the way that it heat their houses. Additionally, if we find the root causes, so the particular households that contribute most to the smog problem, then we could propose those people some professional audits of the properties and suggest the best methods to solve the problem in their houses. It has to be done together with some local authorities. SmogSpots is not going to be another way of finding the people to punish and give another fine. We want to help them in order to understand the problem and together with them and some local authorities to somehow overcome it. Currently, we are trying to extend our initial approach by adding some data which was collected by the satellites. Copernicus is a satellite mission founded by European Union which aims to monitor the atmosphere by providing different satellite images to the public. Those images contain some weather imaging, clouds and smoke, and atmosphere chemistry monitoring. Sentinel, this is how all those missions are called, provide different data with different revisit time and different resolution depending on the mission. So Sentinel from 1 to 5 have different spatial resolution and different revisit time. So the longer the revisit time is, the higher the resolution can be. For instance, for Sentinel-2, we have 10 to 60 meter resolution, but we have the results only for every single 5 days for a particular area. However, if we look at Sentinel-4, then it provides 8 kilometers resolution, but only 60 minutes revisit time, so it's rather fast. However, if we want to find a particular household, or let's say an area where there are several different households, then it might be important to have much better resolution than even those 10 meters. This is how we cannot simply use Copernicus data, but we need to find a way to somehow scale it up. This is how the image from Sentinel looks like. It's the concentration of PM10 dust in Europe for one of the days. And these are the problems that we still see with Copernicus. The resolution of it is quite low, especially if the revisit time is acceptable. On the other hand, when the resolution is high enough, the revisit time is too long, so we cannot use any of the data sources directly. This is why we propose to use upscaling. So it seems to be a solution to obtain some superior resolution images with a reasonable revisit time. And we believe, and this is something that we currently try to build, such a procedure enriched with some ground level measurements like the before mentioned sensors might create an opportunity to have a better overview of the smog flow in the atmosphere, and based on that to detect how each pollution was created, where it started, and how it all together contributes to the overall state of the air. In addition to Copernicus and mentioned data sources, there are also some chemical models like WRF Chem, which tries to simulate the emission, transport, mixing, and chemical transformation of trace gases and aerosols simultaneously with the meteorology. That may allow to investigate the air quality on a regional scale. But we aim to be a bit better and try to find a way of how to simulate the behavior starting from those individual properties So at the end, we can tell that these households contribute most to the air pollution and try to fix that. This is what SmogSpots is about.
So, thank you, Kacper, for your interesting talk. I believe that we do not have any questions from the audience, but I'll have some questions. And the first question is, well, you mentioned that you used explainable AI methods in order to explain feature importance when it comes to predicting PM10 concentration. Which
Yes,
method
exactly.
did you use and why?
Yeah, actually, I've described that on the presentation. That was the permutation importance. Well, that wasn't the best choice. We could probably use some more sophisticated methods like Shapley values, which are like the state of the art, I believe. However, for the purposes of the hackathon, that was rather easy to use the permutation importance, but it's quite easy to understand. And the audience on the hackathon wasn't really technical. So that was rather easy to describe why this approach works. And well, that's a good starting point. If you have like 20 hours to deliver a project, then you cannot simply rely on those, let's say, more complicated methods. That was the only reason. But currently, we are investigating some more approaches like the before mentioned Shapley values, which seems to be much better.
Yeah, cool. Thank you for the answer. So another question would be, what type of model did you use in order to predict PM10 concentration? Was it a linear regression?
No,
Or
not really. Actually,
okay,
we've been using several models. We didn't test the linear regression, if I remember correctly, but it was like a couple of months ago. But we were mostly working with some tree-like models, tree-based models like XGBoost or random forest. But basically, the best model was based on random forest with like 25 trees underneath. Also, it was chosen only because it's quite fast to be trained, and also quite easy to be explained. So, well, like typically during the hackathon, you cannot use the methods you would like to use, but you still need to keep to those which are efficient and have to be trained in a quite a short period of time, because we didn't know the question of the hackathon before it started. So we just had to first of all think about the proper way of solving the problem, which is quite unlikely, because assigning some sort of probabilities or the contribution of the areas couldn't be easily solved with any supervised method. We didn't have any data that could just tell us that this is the contribution of those municipalities. So we just spent a lot of time just to rephrase the problem in order to somehow approach it.
yeah, cool. So I have a question that's more like open-ended question. What are some other interesting projects that you do at AI Embassy?
Well, basically, we started with the smog spot, but currently we are trying to, due to the COVID, it was stopped. But we are trying to reach as many people as it's possible, and we would like to make. We are currently trying to start a project which will be aimed to the public, and we will try to educate the elderly people, but not only, also those digitally excluded people, about the possible usages of AI in the future. I mean, we are pretty sure that AI will be another revolution, and probably it will be much better for all the people to understand at least what are the limits and what are the possible use cases. Even the deepfakes, which are quite funny. However, it might be in the future. I can imagine that it might be kind of way to cheat the elderly people. So they the those people who try to those cheaters won't just call them, but if instead they will send a fake video with the recording of their children or grandchildren. So definitely we need that. There is a huge opportunity coming from using AI in different businesses. but on the other hand, we still need to educate people, and that's what we would like to do in the upcoming months. However, we cannot simply make the online conference for those digitally excluded people for obvious reasons. So definitely, we still need to wait a bit until this pandemic stops, and then we would like to make like a different events in really small cities, just to talk to as many people as possible who won't be able to hear about AI in any different way. But also some other activities like some research projects. Actually, AMLC is a foundation, so it's rather like a group of AI enthusiasts who would like to, well, how to say it, maybe not change the world, but make it a bit better with applying AI.
Okay, so
and also have some fun with it.
Yeah, cool. I was going to actually ask about the future directions of AI Embassy, but you pretty much answered my question. So thanks you again for your very interesting talk. Kacper, if you would like to add something, then go on, because we have some time till the,
Well, I would just like to thank all of you for the great organization. That was a really impressive conference, because I had the chance to attend to some others in the recent months, but that was really the best organized event that I've seen, at least all the online events I attended recently. So really, that was really a pleasure for me. And well, if some of the attendees have any other questions and want to discuss this SmogSpot project or any other project that we are currently working on, then please write me an email. You'll be able to find my email address on our website. So please feel free to reach me anytime.
Yeah, thank you. Thank you for the nice words.